How you going, guys? Curtis from Cutting Edge Engineering. So today's a really exciting day. We've got a new machine in that we've been given the opportunity to test and demo it and potentially purchase it for our workshop. So what we're going to do is we're going to get this unboxed and show you what we got. So what we got is an i450 arc spray system. This is made by Metallisation in the UK and it's distributed here in Australia by Metal Spray Supplies Australia. And as you can see, we've got a couple of the technicians from Metal Spray Supplies here to help us commission the machine, put everything together and go through the first testing process. And what's really exciting, we are the very first workshop in the world with the i450 model. So Metallisation in the UK is one of the leading manufacturers for arc spray and metal spray systems. And we've been dealing with Metal Spray Supply for years for our consumables for our powder guns. They are definitely one of the leaders here in Australia of supplying thermal spray equipment, and they also supply a lot of the big engineering shops here. So we are in excellent hands and they are just up the road, so if there are any dramas we can just give them a call. So we're going to wheel this over to the lathe and the techs are going to get started connecting everything. So what they're doing is connecting the positive and negative power cables. Now they're going to connect the air lines. There is a supply line goes in the back of the machine and then one comes out the front down to the handpiece. There's also a control cable and all of those get connected into the handpiece. The handpiece is a 145 model. They do refer to it as a pistol and it has 3D printed parts to make it lightweight and comfortable to use. So it's also a push-pull system, which means the wire feeder pushes the wire and the handpiece has a synchronized drive system in it which pulls the wire through the pistol. So they're just filing the ends of the wire to remove all the sharp edges so it doesn't damage the inside of the conduits as the wire is being fed through it. And the next thing they're connecting is the conduits that run the wire from the wire feeder to the handpiece. So they've set this up with a 10 metre supply package, which is pretty standard for a workshop environment. It is also important to have your leads as straight as possible, while also having enough room to work and have the machine far enough away from your job. But the supply package can be customised to any length you need. So now with those laid out, they're just going to go through and zip tie everything together just to tidy everything up. So this new i450 model, the biggest change is the slimline inverter energizer, which does make it more compact and lightweight. It is also the most innovative arc spray technology available right now. So this uses an inverter power source combined with a computerized control circuit and intuitive software to allow you full control to optimize the arc spray. This is 450 amps at 100% duty cycle, and because it is an inverter power source, it can also be used as a welder, but we're not going to be doing that. We're going to leave it set up for arc spraying. It also has a user-friendly interface and push buttons for controls. And on top we have the wire feed system. Because this is an arc spray machine, there are two wires, and to feed those wires you do need a very heavy duty drive unit. So this has a VFD to control the motor and a multi-roller drive system to feed the wires through the conduits up to the handpiece. So this machine is set up with R20 wire. It is a one-step coating. It has excellent machinability, high resistance to corrosion, and it is perfect for the work that we do here. But there is a pretty big range of wires you can use for bond coating and build up for different applications. But for now, we're going to stick with this wire because it is quite forgiving and we're only doing practice runs. So that's just a general overview of the system, but because it is still very new to us, there are going to be things we have to learn along the way. So now with that done, we can turn it on and get ready to test it. So we're lucky enough that our supplier has pre-programmed settings in the machine for our application. So we're just going to scroll through to check all those using the touch buttons.
Over the cross, you got your volts, so if you want to change your set point, do it through here. Air pressures, everything's pre-set up for you guys for engineering. Wire selection, steel, so engineering wires, S2, S20s. Across here is wire sizes. And basically ready to go.
Wow.
And everything looks correct, so we're going to use the wizard for the wire loading. And the wizard makes it really simple. All you need to do is select the wire size you're running, and then we select our feed distance, or how long our supply package is, which ours is 10 meters, which means it'll take about 40 seconds for the wire to go from the wire feeder to the handpiece.
See that gearbox moving as well.
Oh,
So for operator safety and to make sure there is no tangling of the wires, the auto feed does stop just shy of the end of the conduit. What you do then is you use the trigger to then manually feed out the wire out of the conduit, and then you can install it into the handpiece.
Now because you've got this new version,
So that's set up and ready to go. It's pretty simple and straightforward. So the next thing we're going to do, we're going to get a piece of material set up so we can do our first test run. So because this is the first test piece, we're not too worried about the entire procedure. All we're trying to do is make sure the machine and the handpiece are working correctly. So that's the scrap piece of steel prepped. Now we're going to get it out of this lathe, get it set up in the Shenyang, ready for spraying.
spin it. See where we are. Where were we before?
That was 1.5.
So we haven't put much on at all.
Not really.
Alright, let's keep going.
So the way the arc spray system works, it uses an arc to melt the wires. That wire is then atomized using compressed air, and that creates a spray stream which then shoots the coating at the surface. Not only are these used in engineering workshops to build up tolerances on shafts and other components, they can also be used to spray anti-corrosion layers. So you can also run an aluminium and a zinc wire to spray a coating down so it won't rust.
I think that will machine without a problem.
So we've got a thick enough coating sprayed on that. We're going to get it out of the Shenyang, set it back up in the other lathe and see how it machines.
Yeah, we can throw R30 in there, but very popular for seal areas, and like you see, forgiving, you did that without any preheat or anything. See how pretty it feels?
Very nice. Righto guys, so that's our first test piece completed. I'm really happy with how that turned out considering we didn't follow the exact procedures on metal spraying. But that is one of the benefits of using that R20 wire. It is very forgiving, so I'm really happy with how that came out. And first impressions on using the setup, it is very simple and easy to use. The handpiece isn't too heavy and you are quite comfortable. So I also noticed how much quicker it can apply material compared to our old style eutectic powder guns. They are not a very quick process, but this machine is very fast. So after we finished that test, the techs went through a little bit of extra training on the machine and they also went through general maintenance on the handpiece after use. So depending how often you use the arc sprayer will depend how often you pull it apart and clean it. In the handpiece there are two contact tips. They are a two-piece tip, which means you can replace the end as they wear out. As the wire passes through them, it will wear a groove in them, so you do rotate them around to get the longest service life out of your tips. When you're cleaning the handpiece, it is very important to only use brake cleaner because it doesn't leave an oily residue behind, and you also use a soft bristle stainless steel wire brush. Because you are shooting out molten metal, it will get trapped within the gun, and if it does create a bridge between the two contacts on the end of the torch, it will earth out and you will blow the handpiece up. So it is important to follow maintenance procedures so the tools last a long time. So that's the tech's job completed. The machine is commissioned and we have successfully done our first test, but we want to do our own test, so we're going to set up another job and go through the entire procedure with you. So we already have a job lined up to use this machine on. They are a set of D11 blade lift yokes that need to have the surfaces reclaimed, but they're about a 7-inch diameter. So what we're going to do is set up a piece of scrap material that's closer to that diameter and do a test on that. So the first step of the process is preparation. 90% of failures are from inadequate or incorrect preparation of the component. So the first thing is to inspect the component to make sure there is no damage or any cracks that is going to affect the outcome. And then depending on how damaged the worn surface is, it may need pre-machining. And that's where you machine down the worn area to create a nice surface to make sure it's concentric and uniform. So one very important thing to note is that no lubricants or cutting oil should be used throughout the entire preparation process. Anything you apply to it, you will have to clean off in order to spray it. So the next thing we're going to do is undercut the worn area so we can fill it in with the arc spray. This is where some knowledge and experience and some math comes into the process of how much material you remove to how much you have to put back, as well as achieve enough build up so you've got something to machine back to bring the part back into tolerance. So with the undercut, I am using an S&MG neutral insert, and that is so I don't leave a sharp 90-degree edge at the end of my undercut. That's to prevent any cavities being formed in the very corner of the repair. But with the neutral insert, it does leave a bit more surface area for that material to bond onto the part, and that should avoid any issues with the layer lifting. So for this test scenario, we are aiming for a finish diameter of 141 mil. So what I am going to do is undercut the area I'd like to repair, about 2 mil. Then we will apply our build-up layer using the arc spray. We're going to go oversized by about 1 mil to 1.5 mil, and then we should be able to machine that back to size. So with that done, the next thing we're going to do is roughen up the surface, and the reason for that is we need to give the new layer something to stick to and bond to so it doesn't want to come off the shaft. And the method we're going to be using is rough threading. In order to achieve that, I'm going to lower my tool 1 mil below center height and slow down the RPM. So it is very important that the thread is extremely rough. A smooth thread is going to be basically useless. What we're trying to achieve here is to increase the surface area so everything can make a nice mechanical bond and the layer stays on there. So when cutting the thread, it is recommended that you do it in one traverse and you go to full depth immediately and take the cut. Right, so that's all our prep work done. That thread looks really horrible and jaggedy, which is perfect for this process. If this wasn't a regular shaped or flat component, the other method in order to key up the surface would be grit blasting. So I'm going to take it out of this lathe and set it up in our Shenyang. Because it has a lot more wear in it and it isn't used every day, I've sort of chosen it as the machine I'll be doing the spraying in, and then we can do the finer tolerance work back in this lathe. Before we start spraying, I am going to apply a masking no bond compound to the areas I don't want the spray to stick to. So this is just a demonstration of a repair. If this was an actual repair, we wouldn't leave any rust on it. So we're just going to let that dry off for a few minutes and then we're going to give it a preheat. Preheating is not always necessary, but it is an advantage, especially on something this size. The shaft is very cold and it has been outside in the weather, so giving it a preheat, it will remove that moisture and reduce any thermal stresses in the part. So we're going to preheat this to about 60 degrees, which is a good recommended starting temperature. So now that's all done, we can start spraying. So when you are spraying, it is important you keep the handpiece perpendicular with the job. You also want to have a distance of 150 to 200 mil away from the workpiece, and you also want to keep it moving nice and evenly from side to side, so you end up with a nice even coating. And while I'm spraying, I will stop every now and again just to check the build-up thickness and also the temperature, because you don't want this to exceed 150 degrees. So this is different to our eutectic spray system that we have shown in other videos, where it uses a heat source of oxygen and acetylene and a powder as the spray material. That system is really outdated. It is actually 60 plus years old. It does still have its place in the industry, but it is extremely slow, and there are a lot of variables that come into play when using old style technology, and it is very unreliable on these larger repairs. Because you're using a flame heat source, the heat input into the job can get too high and you will need to let the part cool down, which just adds to the time it takes to do repairs. Because of those issues, it's one of the reasons why we've been looking into an alternative and why we're testing the arc spray system. So I have taken some measurements. We are nearly at the correct thickness, but I still need to build up a little bit of material at the ends of the repair. So I'll concentrate the arc spray there. Righto guys, so that coating has the correct thickness across the entire repair area. Now with that done, we're going to let it cool down for a little bit, then we can take it out of the Shenyang, set it back up in the other lathe and machine it back to size.
What are you looking for? What you got? Wait. Hey, what are you doing? What are you doing? You're a menace. Look. That's not a present. No, wait. Look at all these. Look, what's this? All right, come on, let's go. Hey, wait, drop it. Drop it. Drop it. Hey, me.
So I'm just going to take a light cut so I can get a measurement and see where we're at. So you can see where that no bond masking compound was because the material is just flaking off it. So that's our cleanup done. It's measuring it at 141.88. So I'm going to take a 0.7 of a mil roughing cut, and then we can do our finish cut. So now we're going to do our finishing cut, but I'm not entirely happy with that surface finish, so I am going to change the feed rate and hopefully improve it. Righto guys, so I've got that machine to size. I'm really happy with how this machines. There aren't any porosity issues, and you can really see how well that layer has bonded onto the parent material. But the surface finish is not exactly what I'm looking for. On some applications that wouldn't be acceptable. So even though we've got it to size, because this is a test, I'm going to try a different style of insert to try and improve the surface finish. Righto guys, so we did manage to improve that surface finish. It is extremely smooth, but that insert is just not taking it. It is starting to burn up. So what we might have to do is look at a different grade of insert for machining this material. So the last thing we do to finish off the job is clean off that masking compound. So I'm just going to use some emery tape and a little bit of pressure, and it'll just all fall off. So while I was using the emery tape to clean up the rest of the masking compound, I did run it across that machine surface and it has come up really nice. It's not going to change the overall dimension by a great deal, but that is exactly what we're looking for the jobs that we do. But another way to achieve a really nice surface finish would be using a tool post grinder, and that'll be something we'll probably look into. So we're fortunate enough we're able to keep this machine and test it for a little bit longer. I do have a few jobs lined up that I'm going to use it on, and then we can make the decision whether this is a machine for us. But so far I'm really happy with the outcome and impressed with how the machine works. So if we do end up investing in this, there will be a few things we will have to make. I will need to build a trolley for the arc sprayer to live on. I'm also going to need an extraction system behind the lathe to suck away any fumes and smoke. And the last thing I'll need to make is a welding screen just to protect the toolboxes behind the lathe. So I hope you enjoyed seeing this arc spray system being put to use, and you just might see it in the future. Thanks for watching.
It reminds me of Ghostbusters for some reason, like that ghost gun thing.
Right, you ready?
Yep.
Right, you ready? Right, you ready? Right, you ready?
Yep, okay, go.
Right. Where we starting from? This is made by Metallisation in the UK.
UK.
I can't say that word. So the first thing is to inspect the component. So it also has a user-friendly interface with oh fuck me, I just had a moment. So while I was cleaning up, oh fuck off, wind, and you just might see it again. So I'm going to take a 0.7 of a mil roughing cut, and then we can do our cleanup cut. What?
Finishing.
Oh. So I'm going to take 0.7 of a mil roughing cut, and then we can do our cleanup. What?
You just said clean up again.
Oh, really?
So did that stop by itself, or did you stop that?
No, it stops by itself.
Okay.
So it gets to a safe range so it doesn't poke out and stab you in the eyeball.
Oh. That's not what that's designed for, is
It
it?
works for that though. No, that's actually a gauge for
Yeah, that's
different
really
size
cool.
thicknesses.
From our steel supplier. Oh, damn it. Oh my god. Oh my god, man. What a nutter. Where's he? Where'd he go?